All that text you saw flying by in the previous few seconds of footage were taken directly from the first titles of videos I found on YouTube when I typed in the name of the star, Betelgeuse. I guess there is a lot of money to be made, or at least hits to be generated, in fear farming. And yes, if you pop on YouTube to learn about Betelgeuse, and you come across all these videos telling you, oh dear God, scientists are terrified and NASA is worried because Betelgeuse is about to blow, you are encountering nothing but fear farming. Betelgeuse is indeed about to go supernova sometime between now and the next 100,000 years or so. But Betelgeuse is also hundreds of light years away and represents no danger to us. In fact, astronomers and serious stargazers would love for Betelgeuse to go supernova. For scientists, the star has been an excellent subject for studying stellar evolution, especially stars near the end of their lives. And if the star would go supernova, it would provide an excellent example of a supernova in action, showing a giant star's collapse and explosion, and then portraying the rapid development of a new and beautiful nebula, similar to the Crab Nebula in the Taurus constellation. So what we're going to do in this video is look at the story of Betelgeuse, the real Betelgeuse, not the fear-farmed Betelgeuse so popular in YouTube searches. At present, Betelgeuse is a distinctly red-colored star, a red giant that we can see on the shoulder of Orion. But it began its life as a blue star in the Orion-Obi-Wan Association, a significant group of stars that likely owe their origin to the Orion Molecular Cloud Complex. But Betelgeuse was kicked out of the association millions of years ago. This could have been caused by a nearby star going supernova, but more likely happened due to gravitational interplay. Betelgeuse originally held almost 40 solar masses worth of hydrogen. That's nearly 40 times the weight of our own sun, which, put another way, means that at the beginning of Betelgeuse's life, it was an enormous star. In those days, Betelgeuse would have been large enough to form a hypernova at the end of its life. But that's another story, and gigantic stars must be much bigger at the beginning of their lives to form hypernovae, because they burn so hot and energetically that they will throw off vast amounts of their own mass over time. The haze you now see surrounding this massive blue star is the result of the star jettisoning its own mass due to the incredible power of its own internal fusion furnace. Because stars like Betelgeuse can be hundreds to thousands of times more powerful and brighter than our own sun. So powerful, in fact, that their own energy begins a process early in life of self-destruction. A process which carries on through their own stellar evolution, as such stars do not last long, only a few million years. It is estimated that Betelgeuse, over the course of its life, has thrown off as much as 19 solar masses. And now that it has become a red giant, it is throwing off a solar mass worth of matter roughly every 10,000 years. That is an enormous amount of mass loss. So much, in fact, that Betelgeuse is now effectively surrounded by a tiny nebula of its own making. Many sources relate that Betelgeuse started out as a type O star, but new data indicates Betelgeuse is closer and smaller than previously thought, and may have originated as a B-type star. These are blue stars with 2 to 16 solar masses that are curious and especially noteworthy due to strong stellar winds, high surface temperatures, and a substantial attrition of their mass due to their highly energetic natures. We are now pivoting around a B-type star, and here you can see how its extraordinarily rapid rate of rotation deforms the star, making it incredibly oval. B stars often rotate in excess of 200 kilometers per second, and this star, Achernar, rotates at 250. More massive stars have a great deal more hydrogen fuel, it is true, but they burn that fuel much hotter and less efficiently, so they run through their fuel much, much quicker. In fact, while very small stars, such as red dwarfs, the most common type of star in the universe, can live for up to 1 trillion years, gigantic type O and B stars live somewhere between 10 and 100 million years. If Betelgeuse is a type O star, it is between 8 and 8.5 million years old and has exhausted its hydrogen fuel and has become a red supergiant. And this is how it is known that Betelgeuse is on the cusp of going supernova. The red giant phase occurs at the very end of a star's evolution. It is a chaotic time for a star. Among other things, a red giant's brightness varies, something we see in Betelgeuse where its magnitude varies between 0.0 and 1.6. At its brightest, it can be the second brightest star in Orion and the 10th brightest star in the sky. and now in its red giant phase, it is the brightest star in the sky if looked at through the infrared spectrum. It is believed that Betelgeuse began to become a red giant about 40,000 years ago, when it used up all of its hydrogen. But Betelgeuse is massive enough to fuse all the elements of a main sequence star. It will run through helium and carbon and continue to fuse neon, magnesium, silicon, all the way up to iron. However, iron is star poison. Fusion cannot occur past iron, and when a star gets down to producing lots of iron, it literally reaches its very last day. And at that point, it will collapse suddenly at relativistic speed, the mass of the star bouncing off its own core and shattering the star into a supernova. The energy release is so massive that at this point, and only at this point in the star's life, can it create elements beyond iron. And this process is where all of our heavier, rarer elements come from, elements such as gold, zinc, and silver. This nebula, rich in rocky materials and metals, and driven by the incredible force of the stellar explosion, the supernova, will expand out for all time, or at least until it runs into stellar gases, other nebulae, where it will impact those gases, create shockwaves, and this will lead to the formation of new stars and star systems seeded with the rock and metals to make planets. Planets, in fact, that may even have the potential for life. The end of a star is not so much a death as a beautiful renewal. But all of this could happen tomorrow, or it could be 100,000 years or more away, because estimating a star's mass and remaining fuel is no easy task. After Betelgeuse explodes, at the core of its nebula, we will find a remnant of the star it was, a remnant that will last far longer than the current age of the universe. Betelgeuse is massive enough to collapse into a neutron star, and due to Betelgeuse's possible fast-spinning origin as a Type B star, the neutron star itself should also be fast-spinning. A neutron star is the ember of a collapsed star. Without nuclear fusion going on to prop the star up, after the star has blown off most of its mass, what remains collapses down under such immense gravitational pressure that the electrons and protons are stripped away from the nuclei of the atoms from which the star was made. These pure neutrons condense until there is no space between them, forming an ultra-dense and unbelievably heavy material. A single teaspoon of a neutron star would weigh as much as a mountain. Neutron stars often emit intense electromagnetic fields and spin very quickly. And given Betelgeuse's possible fast-spinning origin as a Type B star, this may well be its fate in its final moments of evolution, when the neutron star becomes a pulsar. Rotating forever at an extremely rapid speed, its intense magnetic field forming a lens of sorts, beaming energy away from the pulsar, focused like the light of a spotlight. An endless memorial to remind us of the great star the pulsar once was. Insofar as we know, Betelgeuse has no planets. If it did, they were long since swallowed up by its expansion into a red giant. But, as noted earlier, Betelgeuse is already surrounded by nebulosity of its own creation. In this time-lapse video, you can see Betelgeuse throwing off massive amounts of mass. Due to the enormous amounts of mass the star throws off, as noted earlier, one solar mass every 10,000 years, and the fact that it has thrown off almost half its mass over the preceding 8 million years, it is surrounded by a nebula of its own creation, some 400 AU in diameter, that is 10 times the distance from the Sun to Pluto. And the presence of this nebula contributes to Betelgeuse's appearance as one of the reddest and most dramatic stars in the sky. So, what will we experience from Earth when this great star eventually does go supernova? To be sure, nothing to be terrified about. If we humans are wise enough to survive that far into the future, what those people in those days will experience is the sight of a lifetime. A star coming to its end with a light brighter than that of the full moon, and the emergence of a new nebula on the shoulder of Orion. The stuff of which myths are made. Thank you for venturing into the cosmos with me in this episode of Sky Story. Sky Story is part of the UNDERSTORY network, a collection of programs devoted to the study of the natural world. In Microstory, we study the invisible world of the very small. In Understory, we examine natural history and issues of conservation. And in Sky Story, we look beyond Earth and explore the cosmos. There will be many more episodes, so to keep abreast, please take a moment to subscribe, and don't forget to hit that like button.